imagine, for a quiet moment, the bottom of the world, where a continent twice the size of Australia lies hidden under a sheet of ice almost 3 miles thick. Before we go any further, if you want a brand new Earth topic every single night to fall asleep to, subscribe. One tap and a new story is waiting for you every evening. From high above, Antarctica looks like a single pale shape pressed against the southern edge of the globe. It glows softly in the long polar light. It seems still. It seems simple. It is neither of those things. Drift down slowly through the cold, clear air. The first thing you notice is the silence. Not an empty silence, but a deep one, the kind that has weight. The wind moves across the surface in long, slow rivers, carving the snow into ridges called sastrugi, which are small frozen waves that catch the low sun. There are no trees here, no towns, no roads, only ice and more ice, stretching in every direction until the curve of the earth folds it out of sight. Now imagine standing on that ice. Beneath your boots, the white surface looks solid and permanent, but the ice under you is moving. Slowly, patiently, it slides toward the sea. In some places, it creeps a few feet a year. In others, it surges. And below all of that motion, far below, hides a whole world that almost no human eye has ever seen. Buried under the Antarctic ice sheet, there are mountains, tall ones. The Gamburtsev Range, locked deep beneath the eastern plateau, rises to heights similar to the European Alps. No climber has ever touched their peaks. No sunlight has reached their slopes in tens of millions of years. We know they are there only because radar signals, bounced down through the ice, return strange echoes that draw the shape of jagged stone. There are lakes down there too, hundreds of them. Liquid water sealed away under miles of frozen pressure, kept warm by the gentle heat rising from the rock below. The largest of them, Lake Vostok, is roughly the size of Lake Ontario. It has been cut off from the open sky for somewhere between 15 and 25 million years. What lives in that water, if anything lives there at all, is still an open question. Some samples brought up from near its surface have hinted at microbes, tiny single-celled creatures. Others have suggested contamination from the drill itself. The debate is not settled. There are rivers under the ice, slow and hidden. There are valleys cut by ancient water. There are places where the gravity of the earth dips in odd ways, suggesting buried basins or dense masses of rock whose origins remain unclear. One such dip in a region called Wilkes Land has been measured carefully from satellites. Some researchers think it marks an old impact crater. Others suspect it is simply a deep geological feature, a scar from the slow shifting of the continents. The evidence does not yet point firmly either way. This is the strange truth of Antarctica. The continent we can see, the white shield at the bottom of our maps, is only the lid. The real story sits underneath it, locked in darkness, pressed flat by the immense weight of the ice. We have mapped the surface of Mars in more detail than we have mapped the rock beneath this part of our own planet. Think about that for a moment as you settle into the quiet. There is a place on Earth larger than India and China combined, where most of the ground has never been seen. Not by satellite, not by camera, not by any living eye. We send radar pulses down and listen for what comes back. We drop instruments into narrow boreholes. We sail along the coasts and watch the icebergs calve into the sea. From all of this, we sketch a rough picture. But the picture is full of soft edges and missing pieces. Tonight, over the next few hours, you and I are going to wander slowly through that picture together. We will sit beside lakes that have never reflected the moon. We will pass mountains that no one has named because no one has stood near enough to name them. We will follow rust-red water that pours from a glacier for reasons we still partly guess at. We will listen for the slow groan of ice that sings as it cracks. None of these mysteries will be solved tonight. That is not the point. The point is to rest in the company of a continent that still keeps its secrets, and to let your mind drift softly into the cold and beautiful unknown. Beneath the great white shield of Antarctica, there are lakes. Not frozen lakes, not lakes that once were. Liquid lakes, full of dark water, sealed away from the sky by miles of ice. The sun has never touched their surfaces. The wind has never rippled them. They sit in perfect black stillness, and most of them have never been seen by human eyes. To picture this, imagine standing on a flat plain of snow that stretches in every direction. The horizon is white. The sky is pale. Beneath your boots, the ice goes down farther than the deepest skyscraper is tall. And then, somewhere in that buried dark, the ice ends and water begins. That water has been hidden for a very long time. In some places, perhaps for millions of years. Scientists have mapped more than 400 of these hidden lakes so far. Some are small, no larger than a pond. Others are immense. The largest known one is called Lake Vostok. It sits beneath the ice in the eastern half of the continent. It is roughly the size of Lake Ontario in North America. If you could lift the ice off the top of it, you would see a body of water about 160 miles long and 30 miles wide. The ice above it is more than 2 miles thick. That is taller than 10 of the world's tallest buildings stacked on top of one another. The water in these lakes stays liquid for a few quiet reasons. The weight of all that ice above pushes down with tremendous force, and that pressure lowers the freezing point of water. Deep heat from the rock below also seeps upward in slow, gentle warmth, and the ice itself acts like a thick blanket, holding in whatever warmth there is. So the lakes sit at temperatures just slightly above freezing, dark, and still, in a kind of suspended sleep. No one knows exactly how old this water is. Some researchers think the water in Lake Vostok may have been sealed off for around 15 million years. Others suggest the water mixes more than we realize and may turn over every tens of thousands of years through slow currents we cannot yet measure. Both ideas remain on the table. The truth depends on how the lake breathes, if it breathes at all. And that is something we have only begun to study. There is also the strange matter of what might live there. In the year 2013, a team drilled down into a smaller hidden lake called Lake Willans. When they brought their sample to the surface, they found microbes, tiny living things, surviving in the cold dark with no sunlight, feeding on minerals from the rock. This was a quiet kind of wonder. Life in a place we had long imagined to be empty. But Lake Willans is shallow and near the edge of the continent. Lake Vostok is deeper, older, and far more isolated. Whether anything lives in its waters remains an open question. Russian scientists drilled down to it in 2012, and the samples they retrieved hinted at possible microbial signatures. Other researchers raised concerns about contamination from the drilling fluid itself. The debate is not settled. We do not yet know if Vostok holds life, or if it is sterile, or if it holds something stranger than either. The numbers around these lakes are hard to hold in the mind. The ice sheet covering them contains about 70% of all the fresh water on Earth. If you melted only the ice above Lake Vostok, you would release enough water to fill many large rivers for many years. And yet, across all of Antarctica, only a handful of the subglacial lakes have ever been touched by a drill. The rest sit in the dark, completely undisturbed, holding whatever they hold. Some of these lakes are connected. Satellites have watched the ice surface rise and fall in slow, gentle pulses as water moves from one buried lake to another through hidden channels. We can see the breathing from above. We cannot see the rivers themselves. The maps we have of this hidden plumbing are sketches, drawn from indirect signals, full of question marks. So when we speak of Antarctica's hidden lakes, we are speaking of a kind of underground country. A country with its own geography, its own rivers, its own slow weather of pressure and warmth. A country we have not visited. A country whose residents, if there are any, we have not met. Tonight, picture that water, dark and patient, sealed beneath the white, waiting for nothing in particular, and possibly waiting for us. To understand how Antarctica came to be the frozen continent we know today, we drift now to a strange place near its eastern edge. The dry valleys. They are not what most people picture when they think of Antarctica. There is no thick blanket of snow here. There is no glittering sheet of ice. There is only bare brown rock, ancient gravel, and a wind that has been blowing across these stones for millions of years. The dry valleys sit between the Transantarctic Mountains and the Ross Sea. They cover about 4,000 square kilometers of exposed land. Cold, dry winds pour down from the high plateau, and these winds carry almost no moisture. They strip the snow before it can ever settle. The result is one of the driest places on Earth. Some patches may not have seen rain or melted snow in 2 million years. Walking through these valleys, you would see frozen lakes capped with thick layers of clear ice. You would see polished boulders that look almost glass-like, sculpted by countless years of grit and wind. You would see soil that scientists once thought was completely sterile, and in the silence, you might begin to imagine the long story this place is trying to tell. The dry valleys are a quiet window into Antarctica's past. Before the great ice sheet existed, the whole continent looked something like this, or maybe even greener. The fossil record hints at forests, ferns, and slow-moving rivers. Antarctica was not always at the bottom of the world. It once sat closer to warmer latitudes, attached to the great southern supercontinent that scientists call Gondwana. Gondwana held together what we now know as South America, Africa, India, Australia, and Antarctica. They were one vast landmass. Then, slowly, over tens of millions of years, the pieces began to drift apart. Antarctica moved south. As it traveled, the climate around it cooled. Ocean currents shifted. New patterns of wind formed in the southern sky. And little by little, ice began to gather. The exact moment when permanent ice took hold is still debated. Many researchers point to a period roughly 34 million years ago at the boundary between the Eocene and Oligocene epochs. The air grew cooler. Carbon dioxide levels in the atmosphere dropped. A circular current formed around the new southern continent, sealing it off from warmer waters to the north. That current still flows today, and it may have been the final push that locked Antarctica into deep cold. But this is only one theory. Other scientists argue that the cooling was more gradual. Some wonder whether the rise of certain mountain ranges far away in other parts of the world altered the global climate in ways we still don't fully understand. Others point to changes in ocean chemistry or to small shifts in Earth's orbit. The truth is likely a tangle of many causes. We see the ice today, but the recipe that made it remains partly hidden. The dry valleys preserve fragments of this story. In their dust, scientists have found pollen grains from ancient plants. frozen lake sediments, they have found tiny fossils of organisms that once lived in warmer water. Each grain, each shell, is a soft whisper from a vanished world. A world where Antarctica still had trees. A world where rivers ran across what is now naked stone. What is harder to know is how the rest of the continent looked during that long transition. Under the modern ice sheet, more than 98% of Antarctica's bedrock is hidden. There may be ancient riverbeds down there, carved when the land was green. There may be valleys, basins, and lake floors that hold the same kinds of stories the dry valleys hold above the surface. Researchers have mapped some of this hidden terrain using radar that pierces through the ice, but the picture is still rough. Whole regions remain blank on the map. So when you imagine Antarctica's birth, hold two pictures gently in your mind. One is the slow drift of a continent across millions of years, settling into the cold. The other is a quiet brown valley where the wind never stops and where stones rest in silence, remembering. Both are true. Both are incomplete. There is something soothing in admitting how much we do not know. The dry valleys do not give up their secrets quickly. They sit, patient and bare, beside the sleeping ice. And the ice itself holds an even deeper memory, sealed beneath kilometers of frozen water. We have only just begun to listen. The story of how Antarctica came to be is still being written, slowly, layer by ancient layer, in places no human eye has yet seen. On the eastern edge of Antarctica, in a place called the McMurdo Dry Valleys, a slow red stain leaks from the white face of a glacier. The ice there is pale and blue and old, but the water that seeps from it runs the deep color of rust, of dried roses, of something almost alive. Early explorers, more than 100 years ago, saw this strange flow and gave it a name that has stayed with it ever since. They called it Blood Falls. The name sounds dark, but the truth behind it is much quieter and far older than any human story. The red color is not blood at all. It is iron. The water that seeps from the glacier is rich in iron. And when that iron meets the cold air above the ice, it rusts. It oxidizes, just as a forgotten nail will turn orange in the rain. The result is a slow, dark bloom of color against the white. The water itself is salty, far saltier than the sea. It is so full of dissolved minerals that it does not freeze even in the brutal cold of the valley, and it does not come from the surface. It comes from somewhere deep below. Beneath the Taylor Glacier, sealed away under hundreds of meters of ice, there is thought to be a pocket of ancient brine, a reservoir of trapped water, cut off from the sun and the sky for a very long time. Some researchers believe this pool has been isolated for more than 1 million years. Others think the seal may be younger, broken, and reformed many times across the ages. The question is still open. What is certain is that the brine is old and salty and dark, and that when it finds a crack in the ice, it rises. The iron in that water has a story that reaches far beyond the glacier. Iron is one of the most common elements in our planet. It sits at the heart of Earth in the molten core, spinning slowly and giving us our magnetic field. It rusts the deserts of Australia red. It runs in the blood of every animal, carrying oxygen through their veins. And yet, every single atom of that iron is older than the Earth itself. It was forged inside ancient stars, in the slow furnaces of their cores, long before our sun was born. When those stars died and scattered their dust across space, that dust gathered, and from it came planets and oceans, and one day, a small red trickle on a frozen continent at the bottom of the world. So when you look at blood falls, you are looking at starlight made solid, the iron in the brine, the iron in the rust, the iron staining the ice. All of it was made in a place that no longer exists. A dying star, somewhere in the deep past, breathed it out into the dark. And here it is now, slowly leaking from a glacier on Earth. The water itself is just as strange. The salt suggests it may once have been part of a sea. Some researchers think that millions of years ago, an arm of the ocean was trapped here as the climate cooled. The ice closed over it. The water became more and more concentrated as some of it froze, leaving the salt behind. Others wonder if the brine was formed by other processes, slow chemistry beneath the ice, the grinding of rock, the seeping of mineral-rich groundwater. The exact recipe is not yet known. What makes blood falls even more curious is what scientists have found living inside it. The brine is not empty. It carries microbes, tiny living things that have somehow survived in the dark, salty cold for who knows how long. They breathe without oxygen. They feed on iron and sulfur. They live in a world without sunlight, without seasons, without any of the things we usually think life needs. How they got there and how they have held on remains an open question. Some think they are remnants of an ancient sea community, frozen in time. Others suspect they have evolved in place, slowly adapting to a world no other creature has ever seen. And so the red stain on the ice becomes something more than a curiosity. It is a window into deep time, into the chemistry of stars, into the strange creativity of life. It links the death of an ancient sun to the salt of a vanished sea, and the salt of that sea to a small living thing that has never known the sky. Everything, it seems, is connected, and much of it we still do not understand. Beneath the wide white skin of Antarctica, there is a mountain range almost no one has ever seen. It is called the Gamburtsev Range, and it sits buried under nearly 2 miles of solid ice. Its peaks are roughly the size of the European Alps. Sharp ridges, deep valleys, jagged summits. Yet from the surface above, there is nothing to mark its presence. Just smooth, pale snow stretching toward the horizon in every direction. The strange thing about these mountains is that no one is sure how they got there. Most tall mountain ranges on Earth form when 2 of the planet's great slabs of rock, called tectonic plates, push into each other. The crust crumples upward slowly over millions of years. That is how the Himalayas rose and the Andes. But the Gamburtsev Mountains sit in the middle of an old, quiet piece of crust. There has been no collision there for a very long time, so the usual explanation does not quite fit. One theory is that these peaks are the cold ghosts of a much older collision from more than 1 billion years ago, when ancient continents pressed together and then drifted apart again. Some researchers wonder if heat trapped deep below caused the crust to lift, like dough rising in slow motion. Others think the ice itself helped sculpt the sharp shapes we now see hidden under it. By carving rivers and valleys before the great freeze locked everything in place. The question remains open. The mountains keep their secret under all that white silence. The forces that shape Antarctica are mostly invisible. Gravity is the loudest of them in its quiet way. Ice is heavy. A sheet of ice 2 miles thick presses down on the rock below with a weight that is hard to imagine. The land beneath the ice has actually been pushed down into the earth, sinking under the load. In some places, the bedrock now sits below sea level, held there by the sheer pressure of frozen water above. If the ice ever melted away, that pressed down land would slowly rise again. This rebound happens elsewhere in the world, where old glaciers once sat. Parts of Scandinavia and Canada are still rising, very slowly, from the weight of ice that melted thousands of years ago. The same thing would happen here, though it would take a very long time. The rock remembers what sat on top of it. Pressure does other things too. Deep inside the ice sheet, the squeeze is so strong that the ice begins to behave in odd ways. It flows, not like water, but like very thick honey poured over a hillside, moving inch by inch over the years. Whole rivers of ice creep toward the sea, pulled by gravity, pushed by the weight of more ice piling up behind them. These slow rivers are called ice streams, and they carry the continent's frozen interior outward, one quiet step at a time. Heat plays its part as well, hidden far below. Antarctica is not a dead, cold rock all the way down. Deep inside the earth, warmth still rises from the core. In some places under the ice, this warmth seems to be stronger than in others. There are hot spots where the bedrock is unusually warm, where volcanoes hide, where the base of the ice itself is melting slowly from below. This melted water collects in pools and lakes, sealed in by the ice above. Why some regions are warmer than others, and how those warm spots formed, is still being worked out. Then there is the magnetic field. Earth's magnetism wraps the whole planet, but the south magnetic pole drifts and shifts around the Antarctic region in ways that are not fully predictable. Compasses behave strangely here. The lines of force dive almost straight down into the ground. What happens to those lines deep below the ice, and how they interact with the iron-rich rocks down there, is one more puzzle held in the cold. Together these forces, gravity pressing down, heat rising up, ice flowing sideways, magnetism turning quietly through the crust, shape a continent that we still only half understand. They have been working for tens of millions of years, sculpting mountains we cannot see, carving valleys we have never walked, melting water we have never tasted, and above it all, the ice keeps its smooth, blank face turned toward the sky. When you picture Antarctica tonight, picture more than just the surface. Picture the Alps hidden under it. Picture the slow press of weight, the slow rise of heat, the slow drift of ice toward the distant sea. All of it moving quietly in the dark, beneath a stillness that only looks like nothing is happening at all. Out on the great white plain of Antarctica, the wind sometimes carries a strange sound. It is low. It hums and groans and slides between notes like a slow voice. Scientists have recorded it for years, especially over the Ross ice shelf. The ice, they say, is singing. The song comes from snow drifting across the surface. Wind shakes the top layer, and the whole shelf vibrates at frequencies too low for human ears. Special instruments slow the sound down and lift it into our range. What comes back is a soft, eerie hum, like a deep cello drawn across a frozen string. We can hear it. We do not fully understand it. Why the pitch shifts from day to day. Why some storms make the ice moan and others make it whisper remains an open question. To feel the size of what is singing, picture this. The Ross ice shelf alone is about the size of France. It floats on the sea, hundreds of meters thick, and it is only one of many. The whole Antarctic ice sheet covers roughly 14 million square kilometers. If you laid it over the United States, it would bury every state and spill into Mexico and Canada. If you laid it over Europe, almost nothing would peak above the white. Now picture its depth. In some places, the ice is nearly 5 kilometers thick. 5 kilometers. That is taller than most mountains people climb. If you stood at the bottom of the ice and looked up, you would see no sky. You would see frozen water pressing down on you with the weight of a small mountain range. Stack 13 Eiffel Towers on top of one another, and the ice over central Antarctica would still be deeper. The numbers grow stranger when you think about volume. Antarctica holds about 26 million cubic kilometers of ice. That is roughly 70% of all the fresh water on Earth. Every river, every lake, every drop of rain in every cloud above every continent, most of it is not in the rivers or the clouds. Most of it is here, locked into a slow white silence at the bottom of the world. If all of that ice melted, the global sea would rise by about 60 meters. Coastal cities would sit beneath the waves. Whole nations would change shape. The melting would take a very long time, and most scientists do not expect it soon. Still, the scale of what sleeps under that white surface is hard to hold in the mind. Age adds another layer. The deepest ice yet drilled in Antarctica is roughly 800,000 years old. Tiny bubbles trapped inside it hold air from a world before written history, before farming, before the first cave paintings. Researchers are now hunting for ice that may be 1.5 million years old. Some believe it sits somewhere near the Dome Sea region, waiting to be found. Others wonder whether such old ice has already been crushed and lost by the slow movement of the sheet. The question is open. Temperature, too, is hard to picture. The lowest natural air temperature ever measured on Earth was about -89 degrees Celsius at Vostok Station on the high plateau. Satellite readings have hinted at surface temperatures even colder, near -98. At those numbers, your breath freezes the moment it leaves your mouth. Steel grows brittle. Plastic snaps like glass. And yet, kilometers below that frozen surface, liquid water still pools in hidden lakes. The contrast is almost unbelievable. The ice itself is in motion, though it moves at a pace the eye cannot see. Most of the sheet creeps toward the sea at a few meters per year. In some glaciers, that speeds up to a kilometer or more. The whole continent is slowly flowing outward, like a flat, frozen drop spreading on a cold plate. The song of the ice may be part of that flow. The soft music of an enormous body shifting against itself. Stand on the surface, and none of this is visible. You see only a flat, pale field stretching to the horizon. You hear only the wind. Underneath, mountains, lakes, rivers, and rock are pressed down by an ocean of frozen water. The sound recordings remind us that the silence of Antarctica is not really silence. It is a hum we are only beginning to listen to. How much of that hum we will ever decode is not yet clear. Some researchers think the songs may help us track the health of the ice itself, listening for cracks before they appear. Others think the sounds are simply the breath of something too large for us to fully measure. Tonight, the ice is still singing. We are still learning the words. Imagine for a moment that you could walk across the surface of Antarctica's frozen sea. Not the land, the sea. In winter, the ocean around the continent freezes outward in a vast ring, doubling the size of Antarctica itself. The ice spreads like a slow white tide, locking the water into a still, pale floor that stretches farther than the eye can follow. Beneath your boots, the sea ice would feel hard and slightly springy. It is not the same as glacier ice. Glacier ice is old and pressed and blue. Sea ice is younger, thinner, and full of tiny pockets of salty water trapped inside it. If you knelt and looked closely, you might see those pockets glittering like small wet jewels. They are called brine channels. Inside them, strange little communities of algae and tiny creatures somehow survive the cold. The surface itself is not flat. Wind shapes it into long ridges called sastrugi. These are firm, carved waves of snow, sometimes only ankle high, sometimes taller than a person. They all point in the same direction, the direction the wind came from. Walking across them is slow work. Your foot rises and falls, as if you were stepping over the frozen wake of an invisible ship. The color of the surface changes with the hour. At noon in the brief summer, the snow burns a clean, painful white. In the long blue twilight of winter, the same snow turns a soft lavender, then gray, then almost black. The sky above it can be every shade of pale, from milk to pearl to the gentle pink of a far-off dawn that never quite arrives. Now imagine that you could see through the ice. Not far, just a meter or two. Below your feet, the underside of the sea ice would not be smooth. It would hang down in soft brown fronds, dyed by the algae that grow on its lower face. Small fish drift through these fronds, and tiny shrimp-like creatures called krill graze along them in clouds. The krill are no longer than a finger, but together they form one of the largest gatherings of life on Earth. We still do not know exactly how many there are. Estimates run into the hundreds of trillions, but the true number remains uncertain. Further down, the water grows colder and darker. The surface above you would look like a glowing ceiling, lit from behind by the pale sun. Cracks in the ice would shine through as bright lines, the way light slips under a closed door. Seals use these cracks to breathe. They keep small breathing holes open with their teeth, returning to the same hole again and again through the long polar night. What lies on the seafloor below this frozen ceiling is one of the least mapped places on the planet. Robotic submarines have crept under the ice in only a few spots. They have brought back images of strange gardens of sponges, soft corals, and creatures with no common names. Some of these animals grow very, very slowly. A sponge the size of a small chair might be hundreds of years old. Some researchers wonder if certain species down there could live for thousands of years, almost frozen in time by the cold. There are also things on the surface that no one fully understands. Now and then, satellites have spotted dark holes opening in the sea ice far from land. These holes are called polynyas. Some are small. Others are larger than entire countries. They appear, hold open for weeks, then close again. One theory is that warm, salty water rises from below and melts the ice from underneath. Another idea is that strong winds simply push the ice apart. Both ideas may be true at different times, in different places. The full picture is still being pieced together. If you stood on the sea ice at night, you would hear it. The frozen sea is not silent. It pops and creaks as the temperature drops. It groans softly when the tide pulls beneath it. Sometimes it gives a long, low boom that travels for miles, as if the whole white floor were breathing in its sleep. And the footsteps in the title are not only yours. emperor penguins walk across this same surface in the dark months, gathering by the thousands to raise their young. Their feet make small, dry crunches in the snow. Their shapes blur into the gray light, then vanish, then return. We have watched them for many years now, and yet they still surprise us. Where exactly some colonies move to in the worst storms, and how they find each other again, remains a quiet, open question of its own. Beneath the white silence of Antarctica, locked inside the stone itself, there is a quiet record of something hard to picture. The continent we know today is cold beyond imagining. The wind there can strip the warmth from skin in minutes. The ice in some places sits more than 2 miles thick. And yet, deep in that ice and in the rocks below it, scientists keep finding the same strange thing. Leaves, roots, pollen, pieces of wood, fossils of trees that once grew where almost nothing grows now. The story they hint at is gentle and astonishing. There was a time, long before any human walked the earth, when southern parts of this frozen land held forests, not sparse little patches, but real woodlands, with ferns at their feet and tall canopies overhead. Fossil hunters working in the Transantarctic mountains have pulled out petrified stumps still standing where they grew. They have found leaves so well preserved that the fine veins are still visible. They have found the pollen of southern beech trees, relatives of trees that today grow in the cool rainforests of Patagonia and New Zealand. How could such a place exist where now there is only ice? That is the open question that hangs over these fossils. The simple answer is that the world itself was warmer many millions of years ago during the age of dinosaurs and into the time of early mammals. Earth's climate ran hot. Carbon dioxide in the air sat at levels far above today's. The poles stayed mild. The ice caps had not yet formed. Antarctica, still attached to other southern lands, sat under sun and rain rather than under endless snow. But that simple answer leads quickly to harder questions. Antarctica, even in a warm world, has a strange feature that does not change with temperature. It sits at the bottom of the planet. For months each year, the sun never rises there. For other months, it never sets. any forest that grew there had to survive long stretches of total darkness, how did those trees do it? How did the leaves photosynthesize? How did the wood lay down its rings under such an odd schedule of light? One idea is that the trees went dormant in the dark months, the way some northern trees rest through winter today, only on a deeper, longer cycle. Another idea is that the climate stayed mild enough, and the dim twilight of polar dusk lasted long enough for some slow growth to continue even in the darker season. The fossil wood holds clues in its rings, but the rings tell a complicated story. Some are wide and even. Some are thin and crowded. Researchers still debate exactly what kind of year these old trees lived through. There is another mystery folded inside this one. The forests did not vanish all at once. They retreated slowly as the continent drifted south and as the climate cooled across long ages. Somewhere in that long retreat, the last tree on Antarctica died. No one knows where it stood. No one knows the species. No one knows the year, even within a 1,000,000-year window. It simply faded out of the rock record, leaf by leaf, until only the ice remained. The fossils that remain sit in odd, beautiful places. In the dry valleys, where the wind keeps stones bare, fragments of old plant life sometimes lie right on the surface, mixed with dust. In the cliffs of the Transantarctic range, layers of coal mark where ancient swamps once rotted into peat. That coal, dark and quiet inside white mountains, is the compressed memory of forests that breathed warm air. Walking past it, a researcher is walking past a season that lasted 10 million years and ended before any human eye could see it. What this hidden record means for the future is itself contested. Some scientists look at the lost forests and feel a kind of warning, since they show how completely the continent's climate can change when the planet warms. Others caution that those ancient warm periods unfolded over time scales so vast that comparison with our own century is uncertain. Both views agree on one thing: Antarctica has not always been frozen. Its ice is younger than its rocks. Underneath the white, there is a green memory. For tonight, it is enough to picture it softly. A low sun, a canopy of strange southern trees swaying in a mild wind, ferns at the bases of their trunks, a river running clear over gravel. No snow, no ice, just a quiet southern forest at the bottom of an older world, waiting in the rocks beneath your feet, holding questions that no one has yet fully answered. Far inland, where the wind has scoured the surface smooth for thousands of years, scientists lower long, hollow drills into the ice. The drills turn slowly, biting downward through layer after layer of compressed snow. What they bring back up looks, at first glance, like a long, pale cylinder of frozen water. But each of these cylinders is something far stranger. It is a column of time. Antarctic ice does not just sit there. It builds. Snow falls year after year, and the weight of new snow presses the old snow into firm pack, and the firm pack into solid ice. Tiny pockets of air get trapped in that ice. Each pocket is a small, sealed bubble of the sky from the day the snow fell. A bubble from last winter. A bubble from 1,000 years ago. A bubble from the last ice age. The deeper you drill, the older the air you hold in your hand. The longest cores ever pulled from the East Antarctic Plateau reach down more than 3 kilometers. The oldest air they have given us is around 800,000 years old. 800,000 winters of snowfall, stacked one upon the next, waiting to be read. Researchers cut thin slices, melt them carefully, and let the trapped gases drift free. They measure the carbon dioxide. They measure the methane. They measure tiny shifts in the chemistry of the water itself, which can hint at how warm or cold the world was when each layer fell. What the cores show very clearly is that Earth breathes. The climate of the planet has risen and fallen in long, slow waves. Ice ages come, lasting around 100,000 years at a stretch. Then warmer periods arrive, shorter and gentler, before the cold returns. The waves are not random. They seem tied to slow wobbles in Earth's orbit and the tilt of its axis. Cycles named for the Serbian mathematician who first worked them out almost a century ago. The ice agrees with the math, mostly, but not entirely. This is where the cycles grow mysterious. The orbital wobbles alone are not strong enough to push the climate as far as it actually swings. Something inside the Earth system must be amplifying the signal. One idea is that ocean currents shift in response to the small orbital nudge, and those shifts move heat around the planet in dramatic ways. Another idea is that ice sheets themselves grow large enough to change how much sunlight bounces back into space, deepening the cold once it begins. A third idea points to the air bubbles themselves, where carbon dioxide rises and falls in lockstep with temperature, suggesting the gas plays a role in steering the whole rhythm. Which of these is the main lever, and which are secondary, is still debated. There is another puzzle hidden in the cores. Around 1 million years ago, the rhythm of the ice ages changed. Before that, the cold came and went on a faster cycle, roughly every 40,000 years. After, it slowed to the long 100,000-year beat we see today. No one is certain why. One theory suggests that slow erosion stripped away soft soils across northern continents, exposing harder bedrock and allowing thicker, more stubborn ice sheets to form. Another points to a gradual drop in atmospheric carbon dioxide that pushed the system into a colder, slower state. The deepest cores so far cannot quite reach back through that transition. To see it clearly, scientists are now drilling for what they call the oldest ice, hoping to find a core that stretches 1.5 million years into the past. Even within a single core, the layers tell smaller stories. Bands of volcanic ash mark old eruptions. Layers of dust speak of dry, windy centuries on distant continents. Some sections show sudden jumps in temperature, where the climate shifted in only a few decades, faster than any orbital wobble could explain. Those abrupt shifts are perhaps the most unsettling rhythm of all. They suggest the Earth does not always change gently. Sometimes it leaps. So the ice cores hum with a slow music, the long breath of the ice ages, the faster pulse of dust and ash, the sudden coughs of rapid change. And inside each bubble, the quiet whisper of an ancient sky. The continent has been keeping this record for hundreds of thousands of years, faithful and patient, layer upon layer, waiting for someone to listen. What we have read so far is only a small portion of the archive. Deeper cores wait. Older air waits. The full rhythm of Antarctica's long, slow breathing remains, for now, only partly heard. There is a place in Antarctica that sits farther from any coastline than any other point on the continent. It has a name that simply describes its loneliness: the Pole of Inaccessibility, not the geographic South Pole, which marks the spinning axis of the planet, not the magnetic pole, which wanders with the moods of the Earth's deep iron heart. This is a different kind of pole, a pole of pure distance, the point where the ocean is farthest away in every direction. To reach it, you must travel through more than 1,000 miles of nothing. Flat, white plains, wind-carved ridges, air so cold and so thin it burns the lungs. There are no mountains here, no exposed rock, no shelter of any kind. Just the slow curve of the ice sheet rising gently toward the high interior of the continent. The surface looks almost motionless, but it is moving. The ice is always moving, sliding by inches each year toward the distant sea. A small Soviet expedition reached this spot in 1958. They built a tiny base, little more than a hut and a few instruments, and they left behind something strange. A bust of Lenin fixed to the roof of the building, facing back toward Moscow. Over the decades, the snow rose around the hut and slowly buried it. Today, only the dark head of the statue still pokes above the white surface, watching the empty horizon. The building beneath it is gone from view, swallowed by the drifting snow. No one lives there. No one visits for years at a time. This is what it means to have neighbors in Antarctica. Even the human traces are isolated, separated from one another by hundreds of miles of frozen silence. A research station on the coast might have warm rooms, hot meals, and regular flights in summer. The Pole of Inaccessibility has none of these things. It sits in a kind of geographic solitude that exists almost nowhere else on the planet. And yet, it is not truly alone. The ice beneath it connects to every other part of the continent. The slow rivers of frozen water that begin near this point flow outward in many directions, feeding the great ice shelves at the coast. The wind that blows across this high plateau pours down toward the ocean as a steady current of cold air, shaping whether thousands of miles away. The interior speaks to the edges, and the edges speak back in a long, quiet conversation of ice and air. Below the surface, there are neighbors too. Researchers believe that subglacial lakes, hidden pockets of liquid water, may exist beneath even the highest and coldest parts of the ice sheet. Some of these lakes might be connected to one another by slow underground rivers. Others might be sealed away completely, holding water that has not touched the open sky for millions of years. Whether the lakes near the Pole of Inaccessibility are linked to the more famous lakes farther away, like Vostok or Willens, remains an open question. One theory imagines a vast network, a kind of hidden plumbing system carrying water from the interior to the sea. Another suggests that many of these lakes are isolated, each one a small sealed world with its own chemistry and perhaps its own life. The science of this hidden network is still very young. Radar surveys can sketch rough outlines of where water might pool. Gravity measurements can hint at where the bedrock dips low enough to trap it, but these tools draw only soft shadows. The real shape of the water beneath the Pole of Inaccessibility has never been measured directly. No drill has reached it. No camera has seen it. The neighbors of the deep ice remain mostly imagined. Above the ice, the sky is its own kind of neighbor. The atmosphere here is thinner than at the coast because the surface sits more than 3 kilometers above sea level. Stars appear sharper. Sounds travel oddly in the cold, dense layer near the ground. Sometimes the horizon shimmers with mirages, ghostly bands of light that lift distant ridges into floating shapes. The interior of Antarctica is one of the best places on Earth to observe the upper atmosphere, precisely because so little else interferes. There is no city glow, no smoke, no neighbor close enough to send up its own light. So this lonely point, this pole of farthest distance, turns out to be deeply connected after all, to the ice that flows away from it, to the air that flows down from it, to the hidden waters that may move beneath it, to the buried head of a statue watching nothing. We do not yet know how many of these connections truly run, or where they lead. The neighbors of the deep ice keep their conversations quiet, and we are only beginning to listen. High above the Antarctic ice, in the long winter dark, the sky sometimes begins to move. Soft curtains of green light drift across the stars. Pale ribbons of red and violet ripple slowly, folding and unfolding without sound. These are the aurora australis, the southern lights, and they are among the strangest, most beautiful sights on Earth. They glow above a continent that already feels like another world, and they have puzzled people for as long as people have stood beneath them. The lights are born far from Antarctica itself. They begin with the sun, which sends a steady stream of tiny charged particles out into space. When those particles meet Earth's magnetic field, most are turned aside. But near the poles, the field funnels them downward into the thin upper air. There they strike atoms of oxygen and nitrogen, and the atoms glow. Green from oxygen low down, red from oxygen higher up, blue and violet from nitrogen. The colors hang at altitudes between about 100 and 300 kilometers above the ground. That much is understood. What is far less understood is why the southern lights, in some ways, behave differently from their northern cousins. For a long time, scientists assumed the two auroras were near mirror images, glowing in matching patterns at the same moment. Spacecraft have shown this is not quite true. The auroral ovals at the North and South poles can be shifted, lopsided, and oddly out of step. One theory points to the tilt of Earth's magnetic field, which is not perfectly centered inside the planet. Another idea is that the solar wind itself arrives unevenly, pushing one pole's lights harder than the other. The question of why the symmetry breaks remains open. The southern auroras also reach some of the most extreme conditions on the planet. At stations deep in the Antarctic interior, the lights can appear directly overhead in air so cold it freezes the breath into tiny crystals. The temperature at the surface can drop below -80 degrees Celsius. The air is thin, dry, and almost perfectly still. Above that frozen quiet, the sky burns with slow green fire. Few human eyes have ever seen it from that exact spot, and most of what we know comes from cameras left to watch through the long polar night. The lights are not only colors, they are also sounds, perhaps. For centuries, people in the far north have reported faint crackles, hisses, and soft pops when the auroras are strongest. Similar reports come more rarely from the south. Recordings made in recent years suggest something real may be happening, possibly tiny electrical discharges in the cold air near the ground. But the cause is still debated. Some researchers think the sounds are produced when a layer of warm air traps charges close to the surface, which then release in small sparks during a strong aurora. Others suspect the human ear is being fooled by something else entirely. The mystery has not been settled. There are rarer sights too. Sometimes a thin, pale arc stretches across the southern sky in a long, quiet ribbon, glowing a soft mauve color. In the north, observers have given this phenomenon a nickname, and the same kind of arc has been seen above the southern continent as well. It is not a true aurora. It seems to form when a river of hot, charged gas flows through the upper atmosphere at thousands of degrees, far above the visible auroral curtains. What exactly makes these arcs appear, and why they come and go so suddenly, is still being worked out. Then there are nacreous clouds, sometimes called mother-of-pearl clouds, which form in the high winter stratosphere above Antarctica. They shimmer in pale pinks, greens, and blues, lit from below by a sun that has already set. They float at altitudes where almost no clouds should be able to form at all, because the air up there is so dry. Their existence depends on temperatures so cold that even the smallest traces of water can freeze into shining crystals. The same clouds play a role in the chemistry that thins the ozone layer each spring, which is one reason scientists watch them closely. How exactly they shape the air around them, season after season, is still being measured. All of this happens above an ice sheet that hides its own mysteries below. The lights overhead and the lakes beneath are linked only by the silence in between. On a clear winter night at the bottom of the world, a single observer could stand on kilometers of frozen water, beneath kilometers of glowing sky, and feel, for a moment, suspended between two unsolved worlds. Neither has has given up its secrets. Both keep glowing quietly while we wonder. Somewhere south of the great frozen continent, there is a point that no map can pin down for long. It is the South Magnetic Pole, and it will not sit still. Each year it drifts a little, sliding across the sea and the ice like something half asleep, never quite settling, never quite returning to where it was the year before. A compass needle does not actually point to the geographic pole. It points to this restless magnetic one. And in the south, that quiet spot of pull has wandered for as long as anyone has thought to measure it. In the early 1900s, explorers tracked it down on land, deep in the white interior. Today it has slipped off the continent entirely, and now drifts somewhere out in the cold waters of the Southern Ocean, well north of the coast. This wandering is one of those small, soft details of Earth that few people ever pause to think about, yet it touches something very deep. The magnetic field of our planet is made far below us, in the spinning liquid iron of the outer core. That metal sea moves in slow, looping currents, and as it flows, it generates the field that wraps around the whole Earth. The poles are simply the places where that invisible field dives straight down into the ground, because the iron deep inside us is always shifting. The field above us shifts as well. The South Magnetic Pole moves a little each year, sometimes only a few kilometers, sometimes more. In recent decades, its northern cousin has been drifting quickly across the Arctic, racing toward Siberia. The southern one moves more gently, in slow, looping paths that scientists trace year by year with sensitive instruments. Why the two poles behave so differently is still an open question. One idea is that the flow patterns in the core are simply not symmetrical, with stronger currents under the north than under the south. Another possibility is that great patches of molten iron, slowly churning thousands of kilometers below the surface, push and pull each pole in their own quiet rhythm. Neither view is fully proven. The core is hidden from us, sealed behind layers of rock we cannot drill through, and we read its motions only by their faint signature at the surface. There is something gentle about this idea. The compass in your hand, if you held one tonight, would be quietly listening to currents of metal deeper than any mine, older than any ocean. The needle trembles because something we will never see is moving. The magnetic field also has a longer story, written in the rocks of Antarctica itself. When lava cools, tiny grains of iron inside it line up with the field as it was on that day. They freeze in place like little compass needles, locked into the stone. By studying old volcanic rock from the edge of the continent, scientists have learned that the field has not only wandered, it has, on rare occasions, flipped entirely. North became south. South became north. The last full reversal happened around 780,000 years ago, long before any human walked on ice. What triggers these reversals remains uncertain. Some researchers think they begin when the core's flow becomes unstable, with smaller pockets of opposite polarity growing until they overwhelm the whole. Others suggest the field weakens first across long stretches of time, then slowly rebuilds in the opposite direction. The signs in Antarctic rock and deep ocean sediment hint at both possibilities, and the question stays open. For now, the southern field is quietly weakening in places, especially in a broad zone over the South Atlantic. The reasons for this soft, slow fading are still debated. It may be a normal flutter in a system that has always flickered. It may be the very early beginning of something larger. No one can say with certainty. Out on the ice, none of this is visible. The wind blows. The snow drifts. The auroras shimmer overhead, painted by the same field that tugs at the wandering pole. A scientist standing at a remote field station might lift a small magnetometer from a case, set it carefully on a tripod, and watch a needle settle into a position just slightly different from the year before. A few centimeters of motion on a dial. A few kilometers of drift across the sea. It is a small thing. It is also a message from the deep, written in iron, delivered through ice, telling us that even the parts of Earth we cannot reach are alive with slow motion. The South Magnetic Pole will keep wandering tonight while you sleep, and tomorrow it will be somewhere it has never been before. For most of human history, the idea of a river flowing beneath a continent of ice would have seemed like a quiet kind of madness. Rivers belonged to valleys and forests, to soft green places where rain falls and gathers. Ice, by contrast, seemed solid and still, a frozen lid over a frozen world. And so, when explorers first reached the white edges of Antarctica, no one expected to find moving water hidden far below their boots. The earliest visitors to this continent could only see what stood above the snow. They mapped coastlines from the decks of wooden ships. They sketched mountain ranges in pencil and noted the color of the sea. The hidden world beneath the ice was simply beyond their reach. To them, the great white sheet was a single frozen mass, sleeping and unchanging. They had no instruments that could see through a mile of ice. That belief held for more than 100 years. Through the long age of polar exploration, through the sledge journeys and the wind-burned faces, the continent kept its deeper secrets quietly to itself. Even the first scientific stations, built in the middle of the 20th century, focused mostly on what lay above. The weather, the auroras, the slow drift of the ice itself. The first hints of hidden water came not from drills, but from radar. In the 1950s and 60s, scientists began flying small planes over the ice with new kinds of instruments tucked into their bellies. These were ice-penetrating radars, machines that sent pulses of radio waves downward through the frozen layers. Most of the pulse would scatter and return after bouncing off the rock below. But sometimes, in certain places, the signal came back strangely smooth. Too smooth, as if something flat and reflective lay between the ice and the stone. For a long time, no one was sure what to make of these smooth echoes. One idea was that the radar was striking a layer of unusually compressed ice. Another was that the readings simply held some error in the instruments. The third possibility, the one that slowly gathered weight, was the strangest. The smooth echoes might be the surface of liquid water. Vast lakes, sealed beneath miles of ice, lying perfectly still in the dark. The debate stretched across decades. Each new flight brought new traces, new flat reflections, new shapes hidden under the cold. By the 1990s, satellites had joined the search, measuring tiny dips and bulges on the ice surface from far above. When the ice sagged in a particular way, it sometimes meant that the bedrock below held water rather than stone. Slowly, a map began to form, not a map of the surface, but of a buried world. Lakes appeared on it, then more lakes, and finally faint threads connecting them. Those threads were the first whisper of subglacial rivers. Some researchers proposed that water might flow between the hidden lakes, draining from one to another through channels carved in rock or melted into the underside of the ice. Others were more cautious. They wondered if the lakes were truly connected at all, or whether each one sat alone in its own quiet pocket. The evidence was incomplete, and it still is. Then came the moment when the suspicion turned into something closer to proof. Satellites watching the ice surface noticed it rising and falling in slow rhythms by several feet over a few years. The simplest explanation was that water was moving beneath the ice, filling one hidden basin, then draining away into another. The continent, it seemed, had a plumbing system, a slow, sleeping circulation no one had ever seen with their own eyes. To this day, no human has watched an Antarctic subglacial river flow. The water is sealed beneath ice that can be more than 2 miles thick. A few drilling projects have reached small hidden lakes, like Lake Willans and Lake Mercer, and pulled up samples of dark, cold, microbrich water. But the rivers themselves remain hypothetical in their fine details. We know they must exist. We do not know exactly where they run, how fast they move, or how often they shift their courses. One theory holds that these hidden rivers are slow and steady, draining gently toward the sea. Another suggests they may surge in sudden pulses, releasing huge volumes of water in events that take place over years. Both ideas remain on the table. Both remain hard to test, so we are left with a strange picture. A frozen continent that hides a quiet, dark river system inside itself, mapped by echoes, confirmed by the rising and falling of the ice above, glimpsed only through instruments, never with eyes. Most people picture Antarctica as a place of cold and stillness, a continent locked in white silence. the idea of fire there feels wrong. Yet beneath that frozen shell, fire is exactly what waits. Hidden under the ice, in places no human has ever seen, volcanoes rest in the dark. Some of these volcanoes are well known. Mount Erebus rises above Ross Island, smoking gently against the southern sky. It holds a lake of molten rock inside its crater, one of only a few such lakes on Earth. The lava there bubbles and churns, glowing red in the long polar night. Steam drifts from its slopes in soft white plumes that vanish into the cold air. Erebus is the visible one. The strange part is what came after scientists started looking deeper. In 2017, researchers studying the West Antarctic ice sheet announced that they had found evidence of nearly 100 volcanoes buried beneath the ice. Most had never been mapped before. They sit hidden under thousands of feet of frozen water, their shapes only hinted at by the gentle bulges and dips in the ice above. To find them, scientists used radar that can see through ice. They flew planes back and forth across the continent, sending signals downward and listening to the echoes. The echoes drew a picture of the rock below, and in that picture, peaks appeared, cones, cratered summits, the signature shapes of volcanoes sleeping in the dark. No one knows for sure how many of these volcanoes are still active. That is part of the mystery. Some may be ancient and dead, their fires gone out long ago. Others may still hold heat. A few may even be erupting right now, far below the surface, melting the ice from underneath in slow, quiet pockets. We simply cannot see them well enough to know. The thought is a strange one. A volcano can erupt in the middle of a frozen continent, and the world above might never notice. The ice would muffle the sound. The steam would have nowhere to go. Only the slow softening of the glacier above might give it away, and even that could take years to measure. There are two competing ideas about what these hidden volcanoes mean for the ice. One view holds that the heat they release is small compared to the size of the ice sheet. The glaciers above are so thick, so cold, and so vast that a little warmth from below would barely matter. The ice would keep its shape, and the volcanoes would simply sit there, quietly humming. The other view is more uncertain. Some researchers wonder whether heat from these hidden volcanoes might lubricate the bottom of the ice. Meltwater could form at the base of a glacier where it meets the warm rock. That meltwater could let the ice slide faster toward the sea. If many volcanoes are active at once, the effect could add up. The question is open, and the evidence is still being gathered. What makes this even stranger is the link between volcanoes and a melting world. If the ice sheet above were to grow thinner over time, the pressure on the rock below would lessen, and rock, when relieved of pressure, can sometimes do unexpected things. In other parts of the world, glaciers melting off the top of a volcano have been followed by increased eruptions below. Whether the same thing could happen in Antarctica on a long enough timescale is something scientists are still trying to understand. The Marie-Bayad land region of West Antarctica seems to hold most of these buried peaks. It is a stretch of land where the crust is thinner than elsewhere, and where heat from deep inside the earth rises closer to the surface. The land there is not as stable as it looks. Beneath the calm white plain, something slow and warm is still moving. There may be more volcanoes we have not yet found. The radar surveys that revealed the first 91 only covered part of the continent. East Antarctica, with its thicker and older ice, remains less explored. There could be entire volcanic ranges sleeping beneath that older ice, waiting to be mapped. Or there could be very few. We do not yet know. It is a quiet thing to consider on a cold night. A continent of ice that is also, in some hidden way, a continent of fire. The two opposites held together in the dark. Steam rising into rock. Lava cooling against frozen water. Whether the heat below shapes the ice above in important ways, or whether it stays a small and local thing, is still a question without an answer. For now, the volcanoes rest, and the ice keeps their secret. Beneath the ice and beneath the cold gray waves that ring the continent, a vast living world moves in slow, patient rhythms. The deep Antarctic water is one of the strangest neighborhoods on Earth. It is dark for most of the year. It is cold enough to freeze the blood of nearly any creature from warmer seas. And yet, it is full of life. Some of that life is well studied. Much of it remains a quiet puzzle that scientists are only beginning to understand. Near the surface, in the brief southern summer, tiny plants called phytoplankton bloom in great drifting clouds. They turn the water pale green and gold. They feed on sunlight, on minerals stirred up by the wind, and on iron carried in from melting ice and dust. These small drifting plants are the first note in a long song. Every other living thing in these waters depends on them, directly or distantly. The next note belongs to krill. These small pink, shrimp-like creatures swim in swarms so large that they can be seen from satellites. A single swarm may contain billions of bodies, moving as one shimmering cloud. Krill eat the phytoplankton. Whales, seals, penguins, fish, and seabirds eat the krill. The whole web of southern life rests on these tiny pink animals. Yet no one is sure exactly how krill survive the long dark winter when the surface freezes. One idea is that they shelter beneath the sea ice, grazing on algae that grow on its underside. Another idea is that they sink into deeper water and slow their bodies almost to stillness. Both may be true in different places. The full picture is still forming. Below the krill, in the deeper layers, the water gets stranger. Fish swim here that have no red blood at all. Their veins carry a pale, almost clear fluid. They have lost the protein that gives most blood its color. Somehow, they still pull enough oxygen from the icy water to live. They also carry a kind of natural antifreeze in their tissues, a chemical that keeps tiny ice crystals from growing inside them. How exactly this antifreeze evolved and how it keeps working at such extreme cold is still being studied. Each new sample raises new questions. Deeper still, on the seafloor, the bottom is carpeted with creatures that look like they belong to another world. Giant sea spiders the size of dinner plates walk slowly across the mud. Soft corals sway in slow currents. Sponges grow tall and pale, some perhaps thousands of years old. Sea stars creep over fields of shells. In some places, scientists have lowered cameras through holes in the ice and seen fish swimming calmly in water that has not felt sunlight in a long, long time. We do not know species live down there. Estimates keep climbing as more samples come up. This deep world does not sit alone. It is tied to everything above it and everything far away. Cold, salty water sinks near the edge of the continent and slides along the bottom of the sea. This sinking water is one of the great engines of the global ocean. It pushes a slow, looping current that touches every ocean basin on Earth. The deep cold born here will surface again, centuries later, near distant tropical coasts. The breath of Antarctica becomes the breath of the world. The connections run both ways. Iron blown off South American deserts drifts thousands of miles south and feeds the phytoplankton blooms. Dust from old volcanoes settles into the snow and ends up in the sea. The sun, even when it hangs low and weak, still drives the whole song. Without that thin southern sunlight, the plankton would not bloom, the krill would not gather, and the fish, whales, and penguins would not have their summer feast. What remains open is how all of this will change as the water itself warms. Some researchers worry that the slow, deep current is weakening. Others find evidence that it is shifting rather than slowing. The krill swarms seem to be moving south, following the cold. Whether the fish with clear blood can move with them, or whether they are trapped by their own perfect fit to the old conditions, is not yet known. The web is tight. A small change in one strand may travel far before anyone notices. For tonight, it is enough to picture them. The pale green bloom on the summer sea, the pink cloud of krill below it, the clear-blooded fish in the dark, the slow garden on the bottom breathing in the cold, and the great deep current carrying that breath outward toward every shore. There is a story that travelers have told for many years, drifting back from the long Antarctic winter with quiet voices and tired eyes. They speak of snow that seems to glow, not brightly, not like a lamp, but softly, faintly, the way a window in a far house might shine through a foggy night. Some have seen it on the slopes of pressure ridges. Others have seen it on the smooth, open plains, far from any base, far from any light. And no one is entirely sure what they were seeing. The continent is changing in small ways all the time. Snow falls and is buried. Wind reshapes the surface into long, low waves that scientists call sastrugi. Ice grains shrink and grow, settle and harden year after year, century after century. And inside this slow, patient transformation, strange optical things can happen. Light gets scattered. Crystals catch the moon. The air itself, full of tiny floating ice needles, can carry a glow that does not seem to come from any single source. One quiet idea is that what travelers see is simply moonlight bouncing in unusual ways. The snow of Antarctica is unlike snow anywhere else on Earth. It is older, drier, packed in stranger shapes. When the moon is full and the air is still, a single beam of light can reflect off millions of tiny facets, spreading into a soft sheen across the plain. The glow in this theory is not from the snow itself. It is from a sky we no longer notice, lit and scattered by the patient geometry of frozen water. Another idea reaches deeper. Some researchers wonder whether tiny living things in the snow might play a role. There are microbes that can survive in the surface layers of polar ice, sleeping for long stretches, waking briefly when conditions allow. A few of them, in laboratory settings, produce faint chemical light. Whether they could ever glow brightly enough to be seen by a human eye in the open Antarctic night is a real open question. Most scientists think the answer is no, but the possibility lingers because so much of the microbial world beneath and within the ice has never been fully studied. There is yet another possibility, gentler still: the aurora, that great curtain of southern light high in the upper atmosphere, sometimes spills its glow down through the air on very clear nights when the snow is fresh and reflective. It can pick up the green and pink of that high light and hold it close to the ground. A walker on the plain might feel as if the snow itself is shining, when really it is only catching the colors of something far above. And then there are the changes happening right now, slow but real, that may be shifting what travelers see. As the climate warms in some parts of the continent, the surface of the snow is changing. Melt ponds form in places where they once did not. Algae, the tiny green and red plants that live on the snow in warmer coastal zones, are spreading. In summer, Whole patches of the Antarctic peninsula now turn a soft pink or pale green from these blooms. From a distance, in the strange light of a polar evening, those patches can almost seem to glow. Whether this counts as the same phenomenon old travelers described, or something new entirely, no one can quite say. What makes the question lovely rather than troubling is how little anyone needs to settle it. The snow has been doing whatever it does for a very long time. The accounts are scattered across journals and letters, told by people who were cold and tired and prone to seeing what the long dark sometimes shows. There is no instrument permanently watching every plane, no camera pointed at every ridge. The glow, if it is real, is patient. It waits for someone to look in the right place on the right night with the right quiet eyes. So the mystery sits there, slowly evolving as the continent itself evolves. The ice grows older. The algae spread a little further each warm season. The moon rises and falls in its long, slow rhythm. Somewhere out on the high plateau tonight, a researcher walking back from an instrument station may pause, look down at the snow at their feet, and notice a faint, even light that does not seem to come from the lamp on their forehead. They will stand still for a moment. They will wonder. And then they will keep walking, leaving the question open behind them, the way every good Antarctic mystery is left, drifting in the cold dark for the next traveler to find. There is a kind of light in Antarctica that exists almost nowhere else on Earth. It is the light that falls on things left behind. Old wooden huts, sledges half buried in drift, tins of food still stacked on shelves 100 years after the hands that placed them there went still. The dry, cold air does not rot with the way damp air does. It does not rust metal quickly. It does not let mold creep across paper. And so the light of the southern sun, low and pale and slow, keeps finding these places year after year, as if waiting for someone to come back. The huts of the early explorers still stand along certain coasts. Their wooden walls have darkened to a soft brown, almost the color of old tea. Inside, the air smells of seal blubber and pine and something older, something hard to name. Shafts of light slip through cracks between the planks and fall across the floor in pale stripes. Boxes of biscuits sit where they were placed. A pair of boots rests near a bunk. A pencil lies on a table, as if someone simply stepped outside for a moment. Researchers who visit these places speak of the strange quiet. The wind howls outside, but inside the huts, the sound is muffled, almost gentle. The light through the small windows is dimmer than you might expect, because frost has built up on the glass in delicate patterns, and the patterns themselves catch the sun in tiny rainbows, scattering it across the inner walls in soft, shifting colors. There are graveyards too, of a kind, not always with bodies, sometimes only with stones, cairns of dark rock piled by gloved hands long ago, marking a place where something was left or where someone was lost. The stones are coated in pale lichens, the slowest living things on the continent. These lichens grow perhaps a millimeter in 100 years. The crust of yellow and green and gray you see on a cairn today began its life long before any human ever set foot on this land. The light that touches it now is the same kind of light that touched it 1,000 years ago. Some of the lost are not marked at all. The continent has swallowed expeditions over the years, gently and without sound. Sledges that vanished into crevasses. Camps that drifted out to sea on broken floes of ice. The bodies of certain explorers were never recovered, though the records say they were carried inside the slow rivers of ice that flow toward the coast. Glaciologists have wondered, in quiet papers, whether those rivers might one day deliver them back. The ice moves only a few meters each year in some places, but it does move, and what enters it tends to come out again, somewhere, eventually. The light that falls on these old places has a particular quality. Antarctic air holds very little dust and very little water vapor. So the sun, when it appears, casts shadows with crisp edges. The shadow of a sledge handle on the snow can look as sharp as if it were drawn with ink, and the snow itself reflects almost all the light that lands on it, sending it back up into the sky, into the underside of clouds, into the eyes of anyone watching. The world feels twice lit from above by the sun and from below by the snow. In the long twilight of polar autumn, different color. The sun rolls along the horizon for hours without setting, and the light turns gold, then pink, then a deep blue that lingers for days. The wood of the old buildings seems to glow softly from within. Researchers who have wintered nearby say the huts can look almost alive in that light, as if they remember the people who built them. What remains a quiet, open question is how long these places will last. The cold preserves them, but the climate is shifting. Warmer summers, more melt, more biological activity in the soil. Conservators work carefully to stabilize the wood, to clear the snow from the roofs, to slow what cannot be stopped forever. No one knows how many more decades the huts will stand. No one knows whether the lost expeditions still riding inside the glaciers will emerge in our lifetimes, or in the lifetimes of people not yet born. For now, the light keeps falling on them. Slow, pale, patient. It touches the old wood and the cairns and the frost on the windows. It asks nothing. It simply waits, the way the continent itself waits, holding its quiet graveyards in a stillness so deep it almost feels like listening. Antarctica is loud in its own slow way. The ice groans as it shifts. The wind hisses across the plateau in long, thin notes. Glaciers crack with a sound like a deep drum struck once and left to fade. And somewhere far below all of this, the rock itself is moving, drifting at the pace of a slow heartbeat. The continent is sliding very slightly across the skin of the earth, the way it has been sliding for hundreds of millions of years. We forget sometimes that Antarctica was not always white. The rocks beneath the ice carry a memory of warmer places. They hold the shapes of plants that grew in mild air. They hold seams of coal, formed from forests that once swayed in a soft southern wind. The continent we know as frozen was once green, and before that, it sat closer to the equator, and before that, it was joined to other lands in a single great mass that geologists call Gondwana. The sounds of that ancient world are gone, but the rocks still hum in a way when seismic waves pass through them. Scientists send vibrations into the ice and the bedrock, and the echoes come back changed. From those echoes, they draw maps. They listen for the shape of mountains buried under the snow. They listen for the curve of ancient coastlines, long since carried south on the slow back of a moving plate. There is a strange chapter in this story, and it touches a question that has puzzled people for a long time. In the early 1500s, a man named Peary Rise drew a map. The map showed the known world as sailors understood it then, stitched together from older charts. And along the bottom of the map, some viewers have argued, there appears a coastline that looks oddly like part of Antarctica. A coastline without ice, as if drawn from a memory of warmer days. This is where the mystery gets interesting in a quiet way. One reading of the map says that what looks like Antarctica is really just a misdrawn shore of South America, stretched and bent by the limits of old cartography. Another reading suggests the map makers had access to even older sources now lost, that might have shown a southern land before the ice arrived. A third view treats the resemblance as coincidence. The human eye finds patterns where it wants to find them. There is no agreement. The map sits in a museum, and its meaning remains unsettled. Geologists, for their part, are certain of one thing. Antarctica was indeed ice-free for long stretches of its past. Roughly 50 million years ago, parts of it held cool forests. Even earlier, dinosaurs walked across river valleys where penguins now waddle. The continent has worn many faces. The trouble is that no human being could have seen the green Antarctica with their own eyes. We came along far too late. So, if the Peary Rise map really does preserve an ice-free coast, the source of that knowledge becomes a deeper puzzle than the map itself. The plates beneath the ocean keep moving, slow and patient. The Antarctic plate creeps outward from a ridge in the Southern Ocean, pushing the continent in tiny increments. The sound of this motion, if you could hear it, would be lower than the lowest note any instrument can play. It would be a rumble stretched across millions of years, a single long breath of stone. Sensors pick up its smaller voices, the gentle quakes, the settling of the crust, the soft creaks where one plate meets another. Listeners at research stations sometimes describe the deep silence of the interior as a kind of pressure on the ears. And yet, in that Microphones placed on the ice have caught surprising things. They have caught the song of seismic waves traveling thousands of miles from distant earthquakes. They have caught the slow tremor of glaciers grinding against bedrock far below. They have caught the eerie tones that ice itself makes as it flexes, a sound some have compared to whale song, others to a distant, low choir. So Antarctica speaks. It speaks of old continents and old coastlines, of plates that wandered and lands that drifted apart. It hums with the memory of forests it can no longer grow, and whether a faded old map preserves a true echo of that warmer south, or whether it is only the wishful pattern-making of human eyes, is a question that still has no clean answer. The rocks know. The ice knows in its way. We are still learning to listen. Around the edges of Antarctica, the ice does not simply end. It floats. Great slabs of frozen water reach out from the land and rest on the sea, sometimes for hundreds of miles. These are the ice shelves, and they are some of the largest moving objects on Earth. The Ross Ice Shelf alone covers an area about the size of France. What makes them so strange is the way they crack. Sometimes the cracking happens slowly over decades as scientists watch and measure and predict. Other times, a piece the size of a city breaks free in a single afternoon, and no one saw the precise moment coming. The math behind this behavior is both elegant and incomplete, and it sits at the heart of an open question. The simple rules are beautiful. Ice flows. It looks solid to our eyes, but on the timescale of years and centuries, ice behaves like a very slow river. The speed of an ice shelf can often be predicted by gentle equations involving thickness, temperature, and the slope of the land beneath. A shelf might creep forward at a steady pace of 1 or 2 kilometers a year. Scientists can chart this motion the way astronomers chart the return of a comet. The cracking, though, follows different mathematics. Fractures in ice depend on stress, on the way force gathers along weak lines and releases all at once. A crack can sit quietly for decades, growing only a few meters each winter. Then, under the right combination of tide, temperature, and pressure, it can race forward at at the speed of a running deer. In 2012, researchers measured a rift in the Pine Island Glacier, extending more than 20 kilometers in a matter of months. In 2017, an iceberg roughly the size of the state of Delaware broke free from the Larsen Sea shelf. Its name was A68, and it weighed about 1 trillion tons. The numbers themselves have a quiet beauty. The ratio of ice that floats above the waterline to the ice that hangs below is roughly 1:9. This means that the shimmering white cliff a visitor sees from a ship is only a tenth of the true mass. Most of the shelf hangs in the cold sea below, sculpted by currents that no human eye has seen. The melting often begins down there, in patterns researchers are still trying to map. The deep question is whether the cracking can ever truly be predicted. One school of thought holds that ice fracture is, in principle, a solvable problem. Given enough data, the exact thickness, the salt content of the water below, the precise air temperature, the stress patterns building over years, a future model might forecast the calving of a great iceberg the way meteorologists forecast a storm. The mathematics already exists in rough form. It only needs better measurements. Another view takes the opposite position. Ice, in this view, is a chaotic system. Tiny differences in conditions can lead to wildly different outcomes. The way a single warm afternoon can decide whether a creek freezes or flows. Under this view, calving may always carry an element of surprise. The equations may sketch the shape of what is possible, but never the exact hour. The question of which view is correct remains open. What is known is that the shelves matter. They act like doorstops, holding back the much larger glaciers behind them. When a shelf collapses, the rivers of ice on land can speed up, sliding faster toward the sea. The Larsen B shelf broke apart in early 2002 in a span of about 6 weeks. The glaciers it had been holding back sped up to many times their former pace. The math of that acceleration is still being refined. There is something soothing in the slow patience of the science. Researchers fly small planes back and forth across the shelves, sending radar pulses down through the ice. Satellites trace the rifts from far above, taking pictures every few days. Numbers gather. Patterns hint at themselves. A long crack, mapped year after year, becomes a kind of slow poem written in fracture lines. Yet the shelves still surprise everyone. In 2021, a section of the Brunt ice shelf broke off after researchers had watched a single crack creep across it for more than a decade. The exact moment of release still came as a quiet shock, witnessed mostly by satellites and by the soft sound of ice meeting open water. The mathematics is elegant. The mathematics is also incomplete. Between those two truths, the great white shelves drift on, cracking on their own schedule, keeping the timing of their largest farewells to themselves. Far beneath the frozen heart of East Antarctica, hidden under more than 2 miles of solid ice, there is a lake. It is called Lake Vostok. It is roughly the size of Lake Ontario, dark, cold, and entirely sealed off from the sky. No sunlight has touched its waters in millions of years. No wind has rippled its surface. No bird has ever flown above it from within its own enclosed world. It rests in absolute stillness, pressed down by the immense weight of the ice above. What lies in that water remains one of the most carefully guarded questions on the planet. And the answer, whatever it turns out to be, depends on a balance so delicate that even thinking about it feels like holding your breath. Consider the conditions that allow Lake Vostok to exist at all. The ice above it acts like a thick blanket, trapping the slow warmth that rises from deep inside the earth. That warmth, combined with the crushing pressure of the ice, keeps the water liquid even though the temperature hovers just below freezing. If the ice were thinner, the lake would freeze solid. If the heat from below were weaker, the lake would freeze solid. If the pressure eased even a little, the lake would begin to change in ways no one can fully predict. Every variable sits inside a narrow window, and that window has stayed open somehow for perhaps 15 million years. The water itself is strange in ways that hint at how fragile this balance is. It holds an enormous amount of dissolved oxygen, perhaps 50 times more than ordinary lake water. The pressure forces gases into the liquid, the way a sealed bottle holds the fizz inside soda. Any life living there would have to tolerate an oxygen-rich environment that would burn most organisms we know, or it would have to find clever ways to protect itself. The question of whether anything lives there at all remains genuinely open. When Russian scientists finally drilled down to the lake in 2012, after decades of careful work, they recovered samples of refrozen water from the top of the lake. Some researchers reported finding traces of unusual microbes. Other researchers suggested those traces might be contamination from the drilling fluid itself. The debate has never been fully settled. One side says life may already be confirmed in some form. Another side says the evidence is too thin, too easily explained by accidents during the long descent through the ice. Both sides agree on one thing: a pristine sample, untouched and uncontaminated, has still never been collected. That caution is itself a sign of how fragile the system is. Scientists fear that the simple act of looking might destroy what they hope to find: a drop of drilling fluid, a stray microbe carried down from the surface, a small change in pressure, and the lake's ancient isolation would be broken forever. Some teams have proposed using clean hot water drills instead of chemical ones. Others have suggested waiting for technology to improve before sampling the deep water at all. The lake has waited millions of years. A few more decades feel reasonable. The wonder of Lake Vostok is not only what might live in it. It is the realization that the entire planet is full of these delicate arrangements. The thin shell of atmosphere that holds our air in place. The slow tilt of Earth that gives us seasons rather than endless winter or endless summer. The distance from the sun, close enough for liquid water, far enough that the oceans do not boil away. The magnetic field that deflects harmful particles, the slow churn of the deep mantle that keeps the surface habitable. Each of these sits inside its own narrow window, and somehow all of them have stayed open at the same time. Lake Vostok is a small mirror of that larger truth. A pocket of liquid water held in place by ice, warmth, pressure, and time, all in quiet agreement. Change any one of them, and the lake would no longer be what it is. change any one of the planet's own delicate variables, and we would no longer be here to wonder about it. What lies beneath Lake Vostok may be nothing more than sterile water, ancient and empty. It may be a hidden community of microbes that found a way to survive in the dark for longer than any of our species has existed. It may be something stranger still, something that does not fit our current categories of life. No one yet knows. The lake holds its answer in patient silence, while we, above the ice, hold our breath and try to learn how to listen without disturbing what we are listening for. Around the entire frozen continent, a great current moves in slow, patient circles. It is called the Antarctic Circumpolar Current, and it is the largest ocean current on Earth. It flows from west to east, sweeping all the way around Antarctica, touching no other land. Imagine a river of cold seawater, thousands of miles wide and more than 2 miles deep, carrying more water than every river on land combined. This current is the slow pulse of the Southern Ocean. It rises and falls. It pulls in. It pushes out. And much of what it does, we still cannot fully explain. The current carries heat away from the continent. It also helps mix the deep ocean with the surface. Cold, salty water sinks near the edge of the ice, falling down into the dark like a heavy curtain. In other places, deep water rises again, bringing old nutrients up toward the light. This rising and falling is part of a system that some scientists call the Great Ocean Conveyor. It moves heat and salt and carbon around the whole planet. The Southern Ocean is one of the most important parts of this system. It is also one of the least understood. Researchers have measured the current with floating sensors, satellites, and ships that push through the wind-whipped waves. They have learned its average speed and its general shape. Yet the deeper they look, the more questions appear. The current does not flow as a smooth ribbon. It twists into eddies, swirling pockets of water that can stretch 100 miles across. These eddies carry heat into places it should not easily reach. Some of them brush up against the floating ice shelves, melting them from below. One open question is how much warm water these eddies are bringing under the ice. Some studies suggest the amount has been growing. Others suggest the pattern shifts in long, slow cycles. We do not yet have enough measurements to know for sure. The Southern Ocean is huge and stormy and far from any port. Even with modern tools, only a small fraction of it has been studied closely. Another puzzle is how much carbon the Southern Ocean takes in. When cold water sinks, it carries dissolved carbon dioxide down with it. This is one of the ways the ocean softens the warming of the air above. But the exact amount the Southern Ocean absorbs in a given year is hard to measure. One year it seems to take in more. The next year it seems to take in less. Some researchers think changing winds are the cause. Others think the deep water itself is shifting in ways we cannot yet see. The question remains open. There is also the slow pulse of the deep water that forms near the Antarctic coast. As sea ice freezes, it leaves salt behind. The water below becomes heavier and sinks. This forms what is called Antarctic bottom water, the coldest, densest water in the world. It spreads along the sea floor for thousands of miles, reaching far up into the northern oceans. Some recent measurements suggest this bottom water has been getting a little warmer and a little less salty. If that trend continues, the whole conveyor could slow down. By how much and how fast, no one can yet say. The mystery deepens when we think about what we do not measure at all. Beneath the sea ice, the water is dark and almost untouched by instruments. Robotic floats can drift through some of it, but many areas remain blank on our maps. The shape of the sea floor itself is poorly known in places. There may be ridges and basins we have not found, channels that steer the deep water in ways we have not guessed. So, the slow pulse of the Southern Ocean keeps its rhythm, and we listen with the few tools we have. We hear part of the song. We sketch part of the pattern. We trace the great current as it circles the white continent again and again, century after century. What is exciting is how much remains to be learned. New sensors are being lowered into the water every year. New satellites watch the surface from above. Autonomous underwater gliders, small and silent, are slipping into places ships cannot reach. Each new measurement adds a single quiet note to the song. Over time, perhaps, we will hear the whole melody. For now, the Southern Ocean keeps much of its rhythm hidden, turning slowly around a continent of ice, breathing in and out at a pace older than memory. We stand at the edge and we wonder, and the wondering itself is a kind of quiet companionship with a world that is still, in so many ways, unknown. There is a strange truth about Antarctica that takes a moment to settle in the mind. It is the best place on Earth to find pieces of other worlds. Across the frozen south, scattered on patches of polished blue ice, sit small dark stones that did not come from this planet. They are meteorites, fallen from the sky over many thousands of years, and the ice has been quietly gathering them like a slow museum. The way it happens is gentle and patient. A meteorite lands somewhere on the high inland plateau. Snow falls on it. More snow falls. The stone sinks into the growing ice sheet and begins a long, slow ride. The ice flows outward year by year, century by century, drifting toward the coast. When it meets a mountain range or a hidden ridge, the ice is forced upward. Dry winds scour the surface. The ice evaporates straight into the air, a process called sublimation. And what was buried for ages is left sitting on top, dark against the pale blue. These places are called blue ice fields. They shine with a soft, glassy color, polished smooth by the wind, and on them, dark stones rest in the open, sometimes for centuries before anyone finds them. Most of the meteorites ever studied by science have been collected from Antarctica. Some came from the asteroid belt. A few came from the moon. A small and precious handful came from Mars, thrown into space long ago by some ancient impact, and finally falling here, on the quietest continent. What will happen to this gathering place in 1,000,000 years is an open question. The ice sheet is not still. It breathes, it shifts, it grows and shrinks across long climate cycles. If the south stays cold, the blue ice fields may keep collecting meteorites for another 1,000,000 years, slowly sorting the gifts of the solar system into neat, dark scatterings. The plateau will keep its long memory. New stones will fall, and the old ones will keep emerging from the ice as it wears thin in the wind. If the climate warms over long ages, the picture changes. The ice sheet could thin. The slow conveyor that lifts meteorites to the surface could falter. Some researchers worry that warming is already affecting the shallowest stones, melting them just enough to sink them back down into the firn, where they become hard to find. Others wonder whether new blue ice fields might form in places that are buried today, opening fresh windows onto the sky's old deliveries. The question of which meteorites the future will see and which will be lost is genuinely unresolved. Step further out in time, and the story grows stranger still. In 100 million years, the continents will have drifted into new positions. Antarctica may not sit at the pole anymore. The supercontinent cycle, that slow gathering and breaking of the world's landmasses, will rearrange the map. The ice that hides the Gamburtsev Mountains may be gone. The blue ice fields may exist only as a memory in old data, recorded by people who lived in a colder age. Push outward to 1 billion years, and even the bedrock beneath the ice will have changed. Rivers that have not run for 100 million years may run again. New mountains may rise where the ice once pressed. The meteorites collected today, sitting in cold rooms in laboratories around the world, may be the only record left of what fell on this place. They will outlast the ice that preserved them. Far beyond that, the sun itself will begin its slow change. Long before it grows into its red giant phase, it will brighten enough to warm the earth past anything the poles have known. The ice will go. The blue fields will go. Whatever meteorites still rest in the deep plateau will be released, scattered across landscapes that look nothing like today's frozen south. They will mix with the rocks of a different world. There is something quietly beautiful in this. The stones came from far away, from places older than the earth itself. The ice held them for a little while in geological terms. People found them, studied them, learned from them. The whole arrangement is temporary, a brief partnership between sky and ice and curious minds. The question of what the blue ice will gather next, and for how long, sits open in the cold air of the plateau. Each year, new stones fall. Each year, the ice shifts a little. Each year, somewhere on a polished blue field, another dark visitor finishes its long ride and waits in silence, for the wind and the light, and perhaps someday a passing scientist to notice it lying there. Let us step back now, all the way back, and look at this frozen southern place from the farthest possible distance. Antarctica is one continent on one small planet, drifting through the long quiet of a galaxy that holds billions of other suns. The ice we have wondered about for so many hours is just a thin, pale layer on the skin of a world that is itself just a speck. And yet that thin, pale layer holds something extraordinary. It holds time. Every snowflake that falls on the high plateau is made of water. Every drop of that water is made of hydrogen and oxygen. The hydrogen formed in the first minutes after the birth of the universe, when everything was still hot and bright and new. The oxygen came later, forged inside the hearts of stars that lived and died long before our sun was born. When those stars exhausted their fuel, they scattered their atoms into the dark. Some of those atoms drifted for billions of years. Some of them found their way into the cloud that became our solar system. Some of them became water, and some of that water in time became Antarctic ice. So the ice itself is ancient in a way that has nothing to do with the calendar. Long before it froze on the southern continent, it was something else. A molecule in a comet, a drop in a warm sea, a vapor in a young atmosphere. The same is true of the iron in Blood Falls, which once lived inside a dying star. The same is true of the calcium in the bones of the seals that sleep on the shore, and the carbon in the algae beneath the ice, and the silicon in the buried Gamburtsev Mountains. Every element in this frozen story was made somewhere else, in some older fire, and carried here by the slow drift of cosmic time. We are made of the same things. The calcium in our own bones came from supernovae. The iron in our blood came from the cores of stars that exploded before the earth existed. When we wonder about Antarctica, we are, in a sense, made of stardust, wondering about other stardust. The mind that asks what lies beneath Lake Vostok is built from atoms that have already traveled across galaxies. The question and the questioner share a single origin. This is why the mysteries of the southern continent feel so large, even when they are small. A sealed lake under 4 kilometers of ice is a tiny pocket of water on a tiny planet. And yet, it may hold life. And life, so far as we know, is the rarest and strangest thing the universe has ever made. If something is living in that dark water, it is part of the same long experiment that produced us. It is another way the universe has found to look back at itself. The future shape of the melting south will be written in human lifetimes. But the deeper story is written in geological time, and in cosmic time, and in scales of time the human mind cannot easily hold. Antarctica was once green. It will not be green again in our era, but the continent itself will keep drifting. The plates will keep moving. The ice will come and go, as it has come and gone many times before. The earth has worn many faces. It will wear many more. And one day, far in the future, our sun will swell, and the oceans will boil, and the ice will lift away as vapor. And the atoms that once made up Lake Vostok will drift back into the dark, ready to become something else. There is a quiet comfort in that long view. The mysteries we have wondered about tonight are not problems to be solved before sleep. They are pieces of a much older story, a story that began before the earth had a name and will continue long after our names are forgotten. We are small. The questions are large. The time is vast. And somehow, in the middle of all of it, here we are, lying still in a warm room, thinking about a frozen continent at the bottom of the world. The ice is breathing slowly tonight. The lakes beneath it are holding their secrets. The hidden mountains are sleeping under their white blanket. The meteorites are waiting on the blue ice for someone to find them. And the stars that made all of this are still turning overhead, far above the southern sky, watching their old atoms wonder about themselves. It is a strange and beautiful thing to be part of. And so we come to the quiet end of our long walk across the frozen south. We have wandered together over a continent we will likely never visit, looking down through ice that is older than any city, older than any written word. We have stood at the edges of lakes that have never seen the sun, and we have listened in our minds to the slow hum of mountains buried under endless white. Think for a moment of what still waits down there. Beneath the smooth, pale surface of the ice sheet, more than 400 lakes lie in darkness. Most of them have never been touched by any drill. Their water moves slowly, in patterns no one has fully mapped. The microbes that may live in them have never been seen by human eyes. We have only sampled a few. The rest on, undisturbed, holding whatever secrets they hold. There are mountains down there too, full ranges of them, with sharp peaks and deep valleys, all wrapped in ice like a sleeping body under a heavy quilt. The Gamburtsev Range alone is the size of the European Alps, and no one has ever stood on its slopes. The rock waits in perfect silence. The shape of those peaks, the rivers that may run between them, the caves that may open in their flanks, all of it remains a question. The gravity readings over Wilkes Land still tug gently at the imagination. Something massive sits beneath that part of the continent. One idea is a great basin left by an ancient impact. Another is a deep plume of denser rock from far inside the earth. The measurements are real. The cause is still open. We may know in our lifetimes. We may not. And then there is the slow, patient breathing of the Southern Ocean, the meteorites that gather on the blue ice like seeds in a furrow, the auroras that drift overhead in green and rose, the soft glow some have reported in the snow on the darkest nights, each one a small thread in a much larger weave that no single mind can hold all at once. Picture the continent now from a quiet height, as if you were drifting just above the clouds. The ice spreads out below in soft, rolling white, touched here and there by long blue shadows. The sun sits low, painting the ridges in pale gold. There is no sound. There is only the slow turn of the planet, carrying that great sleeping land through the long polar night and the long polar day, again and again, as it has for millions of years. And beyond the ice, the rest of the earth turns too. Warm oceans lap against dark shores. Forests breathe out into the evening air. Mountains stand in their old, slow patience. Deserts cool under starlight. Rivers find their way to the sea as they always have. The planet is vast and gentle and far older than any worry that might have followed you to bed tonight. The mysteries we have wandered through are not problems to be solved before sleep. They are simply there, waiting, the way a quiet library waits at night, the books still on their shelves, the lamps still warm. The questions about Lake Vostok will still be questions tomorrow. The hidden volcanoes will still hum under their snow. The lost forests will still rest in the rocks of the dry valleys, fossil leaves pressed into stone, dreaming their long stone dream. You do not have to carry any of it. You can set it down. The scientists with their drills and their long, careful patience will keep asking. The ice will keep its records. The continent will keep its silence. And somewhere, years from now, a small piece of an answer will rise up through a borehole, and the world will know a little more than it does tonight. For now, let your breath slow. Let your shoulders soften into whatever holds you. Feel the small warmth of your own body, here, safe, far from the cold. The earth is turning, slow and steady, with all of us aboard. The southern ice is shining under its low sun. The lakes beneath it are dark and still. The mountains are sleeping. The mysteries are sleeping with them. Whatever waits to be discovered is in no hurry. Neither are you. There will be more questions tomorrow, and more wonder, and more quiet places in the world to think about as you drift off. Tonight, it is enough to have wandered this far together. It is enough to have wondered. Rest now, and let the great white south fade gently from your thoughts, the way fog lifts from a still bay at dawn. Subscribe for a brand new Earth topic every night. One tap, and something wonderful is waiting for you tomorrow. Sweet dreams.